Welcome to your home tutorial, and you're watching first lesson of SQL for Beginners tutorial. And in this lesson we are going to give you a brief introduction about SQL and databases. So let's get started. First of all, let us understand what is SQL. SQL is a small short form of structured query language, and it is also referred to as SQL. Let us concentrate about the word query. What is query? Query is asking query from someone. So the structured query language, in this, query means we are querying something from the database. We are asking something from the database to give some information. But SQL or SQL is not just confined to the query only. We can do a lot of things which we can do with the data using SQL. SQL is basically a computer language which we can use to store the data in the database, retrieve the data from the database, and manipulate the data in our database. And it is based on relational database model, and usually it used to store, retrieve and manipulate the data in a relational database. What is a relational database? We will come to it a little later in this video, and for now we can concentrate about what RDBMS is, Relational Database Management System, use SQL. Oracle, MySQL, Microsoft SQL Server, IBM's DB2, all are the RDBMSs which use SQL as their standard language to store the data, retrieve the data, manipulate the data. What do you mean by retrieving or manipulating the data? Retrieving is just querying the data that you can ask from someone, like you are asking, give me some information about this employee. If we are talking about employee database, this what SQL gonna do? It will give you that information. You want to ask a question from a database, give me all the information in the employee database. It will give you all the information you asked for from the database, and you can manipulate that information. You can analyze that information. You can, and as I said, that SQL is not just confined to querying a database. It can do a lot of stuff you can do with it. You can insert the data, insert the new data to the database. You can update the existing data. You can delete some of the information from the database. You can delete whole information from the database. You can delete the database. You can do lot of such things which we can actually perform with some data. So first let us understand the history of this SQL. SQL was developed in 1970s in an IBM laboratory based on the model given by Dr. Edgar F. Ted Codd, and this model was of a relational database. A relational database model says that we will store information in a tabular form, and all the tables will be related to each other. And this SQL was originally developed for IBM's DB2, which is also an example of RDBMS, or Relational Database Management System. So this Relational Database Management System is based on the model given by Dr. Edgar F. Ted of relational database. So it was, as I said, that it was originally developed for IBM's DB2. Now other databases such as Microsoft SQL Server, Oracle usually use SQL as their base language for storing, manipulating, managing, or retrieving the data from the databases, and manage their database using SQL only. Let us understand what is a database. Database is an organized collection of data of information we want to store. So what kind of information, or what is this organized collection means here? Organized collection means we want to store some data about employee, say. So we store all the data of employee, and that will be known as an employee database. And that information might contain the information about its payroll, the skills the employee have, the basic information about employee like his name, its ID in the company, his phone number, address, etc., etc., and all the information are kept together in one place in an organized manner, and that is known as a organized collection of database or information of the employee. We will organize the information for that employee, and all the information related to employee will go to one database. Employee will be known as a database, and then maybe we want to store some information about the customers, so we will organize that information which is related to customers. Say we have customers personal information like the customer's address, company customer's name, customer's phone number, customer's contact details, and maybe the orders from that customers, the details of that complete details of that orders of the customers. And we also might store the product information in that only in that database. So because it is a related information, and we will put into one database, maybe known as customer. Now, what is the purpose of a database? The main purpose of database is to operate a large amount of information. Supposedly we have information of our customers. We want to store the information of the customer, so we will create a database, maybe name as customer. We will put or store all the information in our database of the customer. The required information of the customer, we will store it at one place. Now we can retrieve that information, because anytime we can retrieve that information. Because we might want to analyze the data. We might need to analyze that how many customers do I have, from which locations the customers do I have, from which location the customers do I have the most. Maybe we want to understand which customer is a big customer, who is a very loyal customer. Say maybe we want to, who is ordering more from us. We want that details. We can analyze that detail. We can get top customers from that database, and we can also analyze which product is which of our product is doing better, which product is ordered by how many customers. So many lots of stuff we can do with the database. This is the main purpose of the database. We might want to make some business decisions based on our stored data, and SQL helps in it a lot. So we have management systems for the databases, and management systems give a way for us to store the data in a database. So we have two kind of management system. One is traditional DBMS and one is relational database management system. Relational database management systems are the extension to our traditional database management system. So we can say RDBMS is a DBMS. All the RDBMS are the DBMS, but DBMS may or may not be a RDBMS. RDBMS are the relational database management systems, which are based on relational model given by Dr. E.F. Codd, as I told you earlier. And it is based on the concept that data will be stored in a tabular form, while database management systems usually store data in hierarchical or navigational form. So it doesn't mean that it doesn't have table, but that those tables are not related to each other. Maybe we store data in tables in DBMS, but in traditional DBMS, so they will not be related to each other. But in RDBMS, the tables will be related to each other. Let us first understand the difference between the database, RDBMS and the DBMS. So RDBMS, as I told you, stores data in the tabular form, and DBMS stores data as a file. This is a very basic and main difference between these two. RDBMS stores data in tabular form, which are related to each other. DBMS stores data as a file. They might store data in a tabular form, but they will not be related to each other. Example could be SQL Server, Microsoft SQL Server, or Oracle on MySQL in case of RDBMS, or the main, I will say, IBM DB2, for which originally SQL was developed. And DBMS uses file system, XMLs, etc. So as you can see that DBMS have used file system. So said that RDBMS can handle large amount of data, DBMS can is for small amount of data. Let us understand. As I told you that DBMS store data as a file. So supposedly we have lots of customers, hundreds of thousands of customers, or hundreds of thousands of order rows from those customers, maybe lots of orders from the customers. So our business is doing great, and we have hundreds of thousands of records about our orders. So if we store it in a file, it will take a lot of time. Say the file is now 2 gig, and we want to open it and retrieve the data. Opening the file will take a lot of resources. On the other hand, RDBMS, as they are based on tabular data, and there is a key associated with each record in a RDBMS, so it is easy for us to retrieve that particular information from that key. We store that key for a record, we hit that key, we ask give me information from this key, and RDBMS will be able to give us only that record, whether it is 2 gig, 3 gig, 4 gig. Anyway, it will be easily, the information will be easily available in the RDBMS as compared to traditional database management systems. So that gives an edge to RDBMS to use RDBMS. Where DBMS will be used? DBMS will be used for small amount of data. Supposedly we are playing a game, and we have profile based games. We store the profile of a user, and if I have a personal computer, how many users will create their profile? Maybe 2, maybe 3, maybe 4. So only 4 users will be using that information, and it will not be very large. On the other hand, I said hundreds of thousands of records are there in the orders, and say thousands or hundreds of users wants to retrieve the data from the order table. DBMS will be very slow, and RDBMS, it will give you data very early as compared to DBMS, because there is a primary key associated with each record, and we can refer to that primary key using pointers directly, rather than a hierarchical model where we have one parent and child, and we have to navigate, because they use navigational approach, so we have to navigate to the record, so we have to open complete file and then take particular record. So RDBMS is an extension to the DBMS. So as I said, that all the RDBMS are the DBMS, but all the DBMS may or may not be RDBMS. Let us now understand the concepts of RDBMS. A relational database management system, as I told many times, that it is based on the model introduced by Dr. E.F. Codd, or proposed by Dr. E.F. Codd, in which we store data in a tabular form where the tables are related to each other. Data is represented in terms of rows in an RDBMS. So how I can say that tables are related to each other? Suppose we want to store information about employees, and we want to store the basic information of the employee. We want to store the skill set of the employee. We want to store payroll of that employee. So we might create 3 tables. One is employee table, let us say one is employee table, one is skills table, one is payroll table. So all the 3 tables will be linked to one entity, that is employee, because skills will be related to employee, and payroll will be related to a particular employee. So that is how the tables are related in RDBMS, and we collect data as a organized set of tables. Now, organized set of tables, as I said, skills, personal information, and payroll. So we organized a collection of data of personal information, put it into one table, say employee, and then skills, put it into another table, say skills, put the information about the employee's payroll and put it into another table. So all are the organized set of tables related to each other. Now let us understand what is a table. Table is a collection of related data. Now again, it is a collection of related data. What is related data? Say we have created supposedly 3 tables. One is employee table, one is employee skills table, one is payroll table. Let us understand the employee table first. What is employee table? It is a basic information of the employee, like employee ID, his phone number, his name, his address, etc. A basic information of the employee, it's his personal information. And another table, it has a related information, employee, and this is skills. So skills are different, related to company equipments maybe, and then it's his personal information. Both are different. So a related data is put together in a table called employee, and a related data is put into another table called skills. Or we can go to example of customers as well. There will be customers basic information available for with us, like its contact details, customer's name, customer's location, and then how many orders the customer has made to us. Both are different tables, both are related. Now personal information is put into one table and order details is put into another table, because those are related data put together in one table. Order details is another table, related to each other, like customers, order number, product. These are related to one thing and all put together in order table. A table is consist of three things: field, column, row. Let us understand these concepts in one Excel file. Let us visualize that this is a table in a RDBMS, although it is not, but let us visualize just to understand the concept. I'll use an Excel file and let us understand what is a field, what is a column, and what is a row out here. Now let us understand the concept of the table using this Excel sheet representation. Supposedly we have put together information of employees' basic data into one table known as employee. So this is a related information we put together, which consists of various information like employee ID, first name, last name, department, phone number, salary. So these are the related information we put together into an employee table. These are the related information about an employee's basic data. And similarly we might want to store skills, and we say that we have a data related to an employee and skills, so we create another table of related information of employee and skills. So now what is a field here? Field, employee ID is a field, first name is a field, last name is a field, department is a field. So this is the smallest entity which represents an information about a record is known as field. So department here is a field which gives information about the department of an employee, maybe whose ID is 1, whose ID is 3, whose ID is 2, and maybe we have another. So of a particular record, it gives information about a particular entity, particular smallest information about that record. Now what is a column? Suppose if I highlight this is a column, a vertical entity which represents all the information of a field. So here if we say that what is a column, department, it will give you all the information about the department we have in our employee table. What is a row? Row is a record. If you highlight this is a row and this is a record of an employee whose ID is 1. It is giving me information about its first name, last name, department, phone number, salary, or you can say employee ID as well, but we know the employee ID, so I'll say it is giving me information about his first name, last name, department, phone number, salary. So if we want to get say information about the field phone number, we can query the database using SQL and ask the database, give me the information where the employee ID is 3 and give me the phone number of that employee. We can fetch that phone number from this field known as phone number. Similarly, now let us also understand the concept of related tables. As I said, we have another table which have set of records regarding to skills of an employee. So say we have employee ID 1 whose skill is SQL Server and whose skill is VB.NET. Similarly, we have employee with employee ID 2 whose skills are Oracle, Java, CH. If you note, you can check that all these three values are 2, which are related to an employee known as, whose first name is Himanshu and last name is Sharma, whose department is R&D, and whose phone number is this, salary is 20,000. So basically this is storing the information of the employee whose name is Himanshu, and his skills are Oracle, Java, C hash, all things. So this employee ID is related to the table employee 1, 2 and 3, and here 2 times 1, 2 times 3 times 2. This makes the representation of data easier. Supposedly if we don't make another table, what we have to do, we will put another field out here, skills, and put say SQL Server, and we will insert another record for this employee, and let us let us copy this information, because we have the information will remain same for an employee, and we will put one skills more here, and that will be say vb.net. So what we are doing, we are repeating this information again and again. Why? This will increase my size. Because we're adding the same number of fields many times. Supposedly this user Nikhil Gupta have another skill set, we will then insert one more, and here then there comes the concept of related data. So here what we do, we put employee ID, we relate the table to this employee ID and put it set. So we have saved the space of say 1, 2, 3, 4, 5 fields approximately. So it will save a lot of data as well, and fetching of the data will be easy for us, and representing and collection is also very organized in such kind of databases. So RDBMS is based on related information, related tables of different related information together. I hope this make you understood the concept of RDBMS and the table, which is a main entity or main object of relational databases, and form a concept of RDBMS. And why we talk about RDBMS more, because our SQL, which we are going to talk about a lot in our coming chapters, are based on relational database concepts given by Dr. E.F. Codd. So let's continue with our presentation. SQL commands. Now let us understand the SQL commands. SQL commands are basically classified into 3 groups. As we have syntax for every other language like C++, C, we have syntax for SQL as well. So we have few commands of SQL, a large set of commands I would say, and which are classified into 3 groups, namely DDL, data definition language, DML, data manipulation language, DCL, data control language. So as the name says, DDL is a language, is a set of commands which are used to define the objects of the database, which can help in a creation of a database, a creation of table, modifying the table, the structure of the table, the structure of the database, or any other object. So data definition are basically related to the commands which can manipulate an object in our database. Suppose whether it will be a view, table, or any other object, say we have in our SQL or in our databases. So there are 3 DDL commands, 3 basic DDL commands, which are create, alter, and drop. Create is used for creating a table or a database or view or any other object. Alter is to modify the current object, and object may be a table. We might want to modify some something in database structure as well, so we can do it using alter command. There is a drop command. If you want to drop a structure, we will use drop command. We'll talk about these commands later as well in our later videos. So for now, this would be okay to understand. The data definition language used to define an object, used to define some object, a structure of an object basically. Now data manipulation language, as we say, we can insert the data, we can retrieve the data, we can manage the data, we can manipulate the data. For that we have DML or data manipulation language. Data manipulation language contains commands which using which we can fetch the information, we can query the database, and we can fetch the information, and later on we can use that fetched information to analyze the data. So the basic commands will be select, insert, update, delete. We're going to talk about them later in later videos, but yes, select is just querying a database and that give me this information, please select only this information for me. Insert is for putting a new information, a new record in a table. Update is to just modify the content of the data, and delete is to delete the data. Just need to understand the DDL and DML difference. DDL based data definition language are used to manage the structure of objects, while DML is to modify or manage the data present in that structure. Supposedly, if we called a structure of a table, we created a structure of a table using DDL command, then a data, as an example of employee table, if I take, so employee ID 1 Nikhil Gupta will be an example of a data, a record. So we can delete that record, we can fetch the information from that record, we can insert the record, a new record. Supposedly we want to put another employee, a new employee came, we want to insert the information of that employee, add the information of that employee, we will use insert command for that. Supposedly the salary of an employee changed, if we want to change the salary of that employee, we can use the update command for that, and we are just manipulating the data but not the structure. Now take another example, we want to add some new field, maybe address field in that employee table. Then we need to go to DDL language. We will use DDL commands for that. Like we can use alter table command to add one more column. We will, as I said earlier also, we are gonna discuss these all in details in my later videos. So for now, this will be okay to understand that data manipulation language is used to manipulate the data in a database. Now data control language. Data control language are used to control the access to an object or data in a database. We don't want to give access to everyone who can perform some action on a database. Supposedly, if I talk about employee table, personal information, I don't want to give access. It can have access to the manager of that employee, that he can change the data. But what about payroll? Only HR department should have the rights to update that information. So let's say the manager of an employee can view the data but cannot update or delete the data. On the other hand, HR can modify the contents of that data, of the payroll data of a particular employee. So using the two commands, grant or revoke, we can use that. We can revoke the rights using revoke commands. We can grant the rights to someone, that you can perform some actions with the database, you can see that data or not, you are not allowed to see the data. So data control language is more used for security purposes. It is to secure the data from unauthorized access. So this is all about DCL, and also this is I'm gonna tell you about grant, revoke and other commands of DCL later on in my tutorial. For now, this is okay to understand that DCL is basically used to control access to the data in a database or is used for security purposes. So thank you for watching this video. If you like this video, please hit a like button and please hit a subscribe button as well, so that you can view my another videos related to this tutorial. I'm gonna show you all the commands of SQL in my later videos. So we will be talking in details about the SQL commands, the various SQL commands we are available, how to use them, and we will be gonna use Microsoft SQL Server for that. So thank you for now. Thank you for watching my video, and please don't forget to hit like and subscribe button. Thank you.